Okay, so today we start prism and we will solve some problem from prism. So the thing is that we know that a simple prism, that is a homogeneous transparent refracting medium, and that is bounded by at least two non-parallel plane surfaces that are inclined at some angle. And we know that prism can have any number of surfaces, but the surfaces on which light is incident and another surface from which light comes out, that should be non-parallel. So both of these surfaces are plane surfaces. So if we write the definition of a prism, we know that a simple prism is a homogeneous transparent transparent refracting medium that is bounded by at least two non parallel plane surfaces inclined at some angle, inclined at some angle. So that is the basic definition of a prism, and we know that a prism that can have, you can say, that is, a prism can have any number of surfaces, but the thing is that the surface on which the light is incident and the another surface from which light comes out, that should be non-parallel. So we know that we can write the prism like that. If a prism is like that, and this, so the thing is that this is nothing but, you can say, refracting edge, that is also, you can say, refracting surface, and of course that is called angle of prism, that is called angle of, should be like that. So we know that that is the commonly used prism, and the two non-parallel plane surfaces that are participating in refraction of light, that is called refracting surfaces, and the line of intersections of the two refracting surfaces, that is called refracting edge, and the angle between two refracting surfaces, that is called the angle of prism or refracting angle, and that is denoted by E. Now we will actually derive a relation, that is one of the important relation. So that is, we are dealing with the refractions due to prism. That means refraction due to prism. Refractions due to prism. Now if we consider refractions due to prism, then what we see that, say this ABC, that is nothing but the principal sections of a prism with the angle of prism A. Say this is A, this is C, this is C, and that is the principal section of a prism of refracting angle A. And say a light, a ray of light, say DE, and that is, say, that incident on the refracting surface AB of the prism, say at an angle I. If we draw the normal, say this angle is nothing but I, and after refraction at E, the ray of light that is bent towards the normal, say this normal is NO, bends towards the NO, and travels say along a path EF. This is the path EF, and the refracted ray EF, this again suffers a refraction at F and bends away from the normal, that is, you can say this is A naught in Pro, and travels along say FG, and travels along FG. So the ray FG, that is called emergent ray, and the angle made by the emergent ray with the normal, that is called angle of emergence, and that can be say E. So when the emergent ray is produced backward, it will meet the incident ray, say that is produced by the forward point at O prime. That means if we move it backward like that, the incident ray is, it will be moving like that. Minute. That means what I want to say, that if we draw this diagram like that, incident ray, say it meet with some point that is called O prime, and the angle between the emergent ray and the incident ray, that is called angle of deviation, and that is denoted by delta, that we know. So if you see that, that is the angle of refraction R1, this is R2, and that is delta 1, and that is delta 2. That means by this particular part, it would be like that. This is the corresponding ray is passing through, that is EF, and that is O point, and say this is O prime. We are taking this angle as delta, and this two angle is delta 1 and delta, and this is R1 and this is R2. That is the pictorial diagram of this figure. So now that is the corresponding thing that I you can say. Now the thing is that since this will happen, this is called delta, is called angle of deviation. So what is the angle of deviation? The angle of deviation is the angle through which the incident ray is turned by the prism. That means this delta is called of deviation, and the meaning of angle of deviation is nothing but is the, you can say, angle through which incident ray incident ray say is turned by the prism, is turned by the prism while passing through the prism. Or in other words, you can say that the angle between the emergent ray and the direct ray is the angle of deviation. That means the angle between the emergent ray and the directions of incident ray, that is called the angle of deviation. So now we have to prove something, that what is the relations between delta and this angle of incidence and all those stuffs. So from that figure, What do you mean by delta 1? If you see the figure, you will find this is the delta 1. If we draw it like that, this is, say, and if we normal, this angle is I. Since this angle is I, then what we can write, that angle I is equals to delta 1 plus R1 is equal to angle I, or you can say delta 1 can be written as I minus R1. That we see the diffraction surface, you will see that in that particular case, if we draw the diagram like that, this is, and if we find that this is nothing but the angle of immersion, this is the angle of immersion, and that should be equals to, you can say, delta 2 plus R2 is equals to, and from that you will get delta 2 equals to E minus R2, that you can get from that. And if we see this triangle, the total deviation, the total deviation that I want to calculate, if this is delta, then this is delta 1 plus delta 2. From that figure you will see that this is delta 1 and this is delta 2, and if we put the value, that means I minus plus E minus R2, so it is nothing but I plus E minus R1 plus R2, so that we get. Now if you consider this particular triangle, that means in that figure, if we consider a quadrilateral, that is A E, that means AE, O, F and A, that means this quadrilateral, this one, this one. If we consider this, what we know that this is the, and the thing is, if we consider this, I am writing there just that it can be understandable. So from, if we say quadrilateral, the name of the figure AEOFA, what we get, the angle A, and that is, you can say, AEO. So the angle AEO plus angle EOF plus angle OF, that should be equals to 360. And of course AEO and AFO, that are all 90 degree. That means we know that AEO and OFA, that is equals to 90 degree. Then what we can write, A plus, this is 90 degree, and this is EOF, and plus 90 degree is 360, and angle A plus angle EOF, that can be written as 180 degree, that we will get from this particular quadrilateral. So the thing is that, again, if we consider the triangle this BOC, if we consider the triangle, this is B, this is O, and if we consider this is C, what we will get, that no, that triangle, if we find that this is, that is EO, if we consider this triangle EO, and this point, this is E, this is A, that means this triangle, if we consider the triangle EOF, then what we will get, EOF, this means R1, this is R2, and the angle is R1 plus R2, and the angle EOF that is equal to 90 degree. Now if we consider, if we compare these two equations, say this is the equation number 1 and this is the equation number 2, then what we find that the angle A should be equals to R1 plus R2. That we can find. That angle A is equals to R1, because you will see that this is R1 plus R, and that is the angle A and EOF. So if we compare these two things, then what you will get? You will get A is equals to R1 plus R2. So the thing is that, so what we get, that angle R1, angle R2 is equals to angle A. And now we just put this particular value in the total deviations, because you will see the total deviations is written I plus E minus R1 plus R2. So if we put it there, then I plus E and R1 plus R2 is angle A. So that we get that the deviations, angle of incidence plus angle of divergence minus, you can say, the angle of the prism. Now the thing is that we have to do it for, you can say, when the deviation is produced by a prism a small angle. That means if the deviation is produced a prism of small angle, that is for very thin prism. That is, deviation is produced by a prism of small angle, that is very thin prism. And since we know the index is, but from the angle of incidence is I and the angle of emergence is R, the angle, and of course since sin I is near about I and sin R1 is near about R1, so you can write I by R1, or you can write I equals to n R1. That we can write angle I equals to n into R1. And also if we consider the refractions at the face AC, refraction at the face AC, that means in that particular phase what we will get, refraction, if we consider like that, refraction at face AC. So if we consider refraction face AC, what we will get, 1 by n is equal to sine R2 by sine angle of emergence, and of course you can write n equals to E by R2. So if we put this value into delta, because delta is equals to I plus E minus A, so I is n R1 plus this is n R2 minus A. If we take common n, that should be R1 plus R2 minus A. R1 plus R2 is nothing but A, so n A minus A. So you will get, if we take n as common, this is A into n plus 1, when the refractive angle is small. That is the one of the formula. The deviations can be written as A n minus 1 if the, you can say, refracting angle is very small. So the deviation that is produced by a very thin prism, that does not depend upon the angle of incidence. That is, for a given prism it is constant quantity, and of course a thin prism that will give less deviation of light, that will give less deviation of light. Now if we just write how we can derive the formula, that is called the one of the important formula, is totally dependent on the particular formula. And that means the angle of deviations, that will depends on the angle of incidence, because what we find, that is I plus E minus A, that is a general formula. And the angle of deviations, you can see that the variations of the angle of deviation with the angle of incidence for a triangular prism, that should be shown like that. That means if this is the angle of incidence and it is the angle of deviation, so we will find that the angle of incidence of a light is, when it is increasing, angle of deviation is decreases till it become a minimum at a particular angle of incidence. Then what will mean? It means that যত আমার angle of incidence বাড়বে, angle of deviations will reduce, and it will reduce up to a certain point, and after that it will again increases like that. And this particular point, at particular point, is called angle of minimum deviation, and that A is equal to E. And of course when A, this refractive index, lambda, whatever be the thing, that are constant. So what I am saying, that from the figure experimentally it is verified that as the angle of incidence, as the angle of incidence of that will increase, the angle of deviation that will decreases till becomes minimum, till it becomes minimum at a particular, at a angle of incidence. And at that particular angle of incidence, the minimum value of the angle of deviation, that will call the angle of minimum deviations. The minimum value of the angle of deviation is called the angle minimum deviation, and it can be denoted by delta m. That is the angle of minimum deviation, and the position of the mini prism at the minimum angle of deviation, and of course that is known as minimum deviation position, and there is one and only one angle of incidence for which the deviation produced by the prism is minimum. That means there is not more than one point or one minimum angle of deviation. Actually there is only one and only one angle of incidence for which the deviation that will produced by the prism is minimum. So now we will show what should be the relations between angle of minimum deviation with the angle of prism on all those stuffs. So if we consider about the condition for minimum deviation, the condition for minimum deviation will be written like that: in the position, in the position of minimum deviation, in the position of minimum deviation, the prism lies symmetrically, the prism lies symmetrically with the incident ray, with respect to the incident ray and emergent ray. That means when the angle of minimum deviation position I should be equal to E. Now we have to prove that. So we know that when we are considering this prism, the diagram is like that. This is the which is coming, and if we draw a normal, this is angle of incidence, and it will be refracted to the prism. And after refraction, say it will be that, and if we, this is the angle of emergent, and if we increase the emergent incident light, and we also like that, angle is nothing but, you can say that, deviation, and this angle is delta 1, this angle is delta 2, this angle is r1, angle is, and from that, when the light ray that is incident on the face, say AB, and refracted into the prism, what we have, the refractive index of the glass, that is prism, with respect to is nothing but sin I by sin r1. And also when the refracted ray is incident at the face AC of the prism, and that will emerge out into the air, then what we will find, that air with respect to glass is nothing but sin r2 by sin E. And since we know that glass with respect to air is nothing but with respect to glass, and from that what we will get, that sin I by sin r1 is equals to sin E by sin r2, and since I is equals to E, we can write r1 equals to r2, and at that particular point you have to find the deviation. So if the angle of the base of the prisms are equal, then the refracted ray that will passes parallel to the base of the prism, and when the prism in the minimum deviation position. So you have to find the refractive index of the material of the prism in terms of angle of prism and angle of minimum deviation. So what we will get, if you find that what should be the basic relations between the angle of deviations, we know the angle of deviation is nothing but I minus, and also we will get plus r2 is equals to a, that we get, and when delta I equals to E. And of course, if we take the r1 equals to r2 equals to 1, prism is in minimum deviation, because we will prove that we will take an a that can be written as, you can write as 2I minus a, because I equals to E. So what we will get, the value of I can be a plus delta m by 2, and also from the equation what is a, this particular equation. So the value of I is a delta m by 2, and value of r is a by 2. So now we know that from the Sen's law, the refractive index is sin I by sin r, and if we put this value, then it can be like that, sin I is a plus delta by 2, and sin r is equals to a by 2, that we will get. So that is the angle of minimum deviation, and the problem becomes by using this equation, that is refractive index of the prism can be found out by using this particular formula. So there is another thing in prism that you can think of, that is called dispersions of light through prism. There is an interesting phenomena that we will see in prism, that when we pass a white light through the prism, it will break into its you can say polychromatic light into its constituent colors. So the thing is that that phenomenon is known as, you can say, the dispersions of light. So what we are saying that, you can say, the phenomenon, the, the phenomenon of splitting of white light, white light, that means this is a chromatic light, and that can be produced by a helium. Helium is producing the constituent color. Say when it passes through a, when it passes through a glass, that is called dispersion of, dispersion of light. And of course that is nothing but that white light through that, then you will find that it will break into constituent color and you will get red, and this is vibrio. So the thing is that, so white light when it is falls on a prism, the emergent line that will consist of different color like violet, indigo, blue, whatever be the, and the red has suffers less deviations, whereas the violet will suffer much more deviations. So that we will find in the experiment. Now the question is, what should be the cause of, what should be the cause of dispersion? So Obhinava bolo to ki should be the cause of dispersion, you think? What is the reason যে এই dispersion হচ্ছে?
স্যার আলাদা ওয়েভলেংথের লাইটটা আলাদা ডিগ্রিতে তোমার রিফ্লেকশন হয় তাই জন্য।
আলাদা ওয়েভলেন্থের লাইটটা আলাদা ডিগ্রিতে ডিফ্রাকশন হয়, এটা বলছো তাই তো? মানে হোয়াইট লাইট মধ্যে ডিফারেন্ট কালার থাকছে, তাই ডিফারেন্ট কালারসে ডিফারেন্ট ওয়েভলেন্থ আছে এবং তার জন্য হচ্ছে, তাই তো? তো সেটা ফর্মুলা জানো কিভাবে হচ্ছে, ভ্যারি করছে ওয়েভলেন্থের সাথে?
না স্যার।
ওকে, so the thing is that the cause of dispersion যেটা ও বললো that is correct, but that will be described by using Cauchy's formula. So actually what we can say that the separation of different colors, the separation of different colors that is present in white light is because of different deviations, because of different deviations that is suffered by them when through a prism, because refractive index of a medium is different for different colors when they, you can say, pass through a prism, because refractive index of a medium is different for different colors, different for different colors. So what we can say that there is a formula by which we can explain it clearly, that is Cauchy's formula, and The formula is Cauchy's, and according to the Cauchy's formula, static index is varied by the square plus either, and when these A and B are constants, and of course you know that lambda is the wavelength of light, and lambda is the wavelength of light. So this relation shows that refractive index of the material or medium, that is depends upon the wavelength, and you can say that n is refractive index proportional to. So of course the wavelength of different colors is different. You know that red colors has the maximum wavelength and the violet color has the minimum wavelength. So you can say that lambda of violet. So for refracting index of the red, that should be less than refracting index of the violet, that is inversely. So now if we consider a small term, then what we know, the deviation formula is that a minus 1 into a. So for red light, the deviation should be equals to refractive index of red minus 1 into angle, and the deviation for violet, that should be like that. Since what we know that this a naught is less than n to reduce, the deviation of red should be, so red color that deviates least and the violet color that will deviate more. So the violet color is seen at the bottom and the red color is seen at the top of the spectrum of the white light. And also if you draw the graph between this, and you know that if we draw the graph between lambda, it should be similarly like that. You can say that that is the cause of dispersion, and you can explain it by using the, you can say, the Cauchy's relation. Now the thing is, there is a classical experiment that is done by the Newton, that you can say if we just give a white light uh, into a prism, and then we observe that the white light, that actually is a beam of many rays of light, and white light is split into each component color, we know, by the prism. So each color is due to some wavelength of light, and refracting index of the prism is different for different wavelength. So the red component of the light, that will bend the least, and whereas the violet component of light bends most. And when an inverted prism that will be placed near the first prism, it reverses the actions of the first prism. So the output that you get from the second prism is again white light. What he said, that they will take two prisms and one is take like that, so it will break the light into 7 different components. Now if we take another prism way, then what will happen, if we just give white light, actually it will break into say 7 components. After it will goes through like that, and it will again, just like that. Mhm. That means they will meet at single point, and then they will break like a white light. That is the principle, that if we get white light wave and we placed an inverted, you can say, another prism, that we get nothing but a white light. Now a simple questions that will come in different boards, as well as it can be taken as a simple questions, that say that is a prism is given like this. You will tell me the answer. This prism that is given, and of course there is a blue light, and there is a green light, there is a red light. This red light that is incident in the prism, that is a right angled prism, and say this is that they will make an angle 45 degree and this also 45 degree, and the question is an refractive index of material of prism, that is material of prism for red light, for green light, and for you can say blue light, that is given 39, 1.44 and 1.47. So the question is which color will emerge out of the prism, which color you can emerge out of the prism, which color will emerge out of the prism. তো স্নেহা বলো তো এটা কোন কালারটা বেরোবে? The question is clear, I think so, that blue, green and red, these three light that is incident on a you can say right angle prism, and the refracting index that is given for different lights red, green and blue. So the question is simple, which color will emerge out of the prism? বলো দেখি, স্নেহা শোনা যাচ্ছে? বা অভিনব বলো? কি মনে হয় what should be the output?
রেড লাইট বেরোবে।
Red
না কারণ স্যার রেড লাইট টোটাল ইন্টারনাল রিফ্লেকশনও খাচ্ছে না আর ক্রিটিক্যাল অ্যাঙ্গেলও যাচ্ছে না, ওটা পুরোপুরি বেরিয়ে যাচ্ছে রিফ্র্যাক্টর।
okay, the thing is that uh, we know if we consider the AB phase, here the angle of incidence reflection is also fall on the face this AC fall face AC at 45-degree angle without suffering any refraction. You can say suffering any refraction, any refraction at face AB. So the phase AC will not allow the emergence of light if the angle of incidence should be greater than the critical angle. So what we can say that phase AC allow emergence of light if the angle of incidence is greater than the critical angle. So if angle of incidence greater than, we can write like sin I sine, so sin I should be greater than sin, or you can write that greater than equal to sin C is 1 by refractive index, and sin I that is given, this is the angle of incidence. So what we can write, the sine 45 degree, that should be 1 by n. So n is greater than root 2 or is greater than 1.41. So in that particular figure you will see that the out of the given color only red will emerge because the refractive index of red is less than 1.41. That means the light which has a refractive index which is greater than 1.41, that is in the case for the green light, and you can say blue light, that will coming out, and the red the only the light, that is a red light, that will not will emerge out, because other will phrase the angle is greater than, you can say, the critical angle, then what will mean that the internal reflection, total internal reflection will occur. That means only the red light whose refractive index is less than 1.39, that can only emerge out. Okay, so that is the questions, one type of questions that may come. Now the thing is that there is another thing that you should know the formula, that is angular dispersions and dispersive power. That is the two things, and you can say dispersive power. Angular dispersion and dispersive power. So if we say about the definition of angular dispersions, that is, you can say, defined as the difference in the difference in the deviations, that is two extreme colors, that is, you can say, red and violet, that are the two through a prism, passing through a prism. What I want to say that if we consider this is a prism and say this is the white light, then what will happen, that say the red light and this is the division of violet light, consider that after reflections to the surface, it will emerge out like that. Say it will be emerging out like that. This is violet. Then we dot a deviation is for, you can say, violet light. Maximum deviation is possible for violet light, and minimum deviation is for red light. Now actually this angular dispersion theta is nothing but the deviation of light, deviation of red light, that you can say that is nothing but the definition of angular dispersion. You will find it by with respect to refracting index also, because if we uh, consider the small prism, if we consider small prism, then what we will know that the value of, you can say, delta, the value of delta is nothing but, you can say, that is for small prism, that is n minus 1 a, and for red color we know the deviation is, and it can be written like that, and we can write like that, nb minus 1 a, and the definition of theta is nothing but the deviation of violet minus deviation of red. If we put this formula, then we will get the refractive index of violet minus refractive into a. And what do you mean by dispersive power? That is the angular dispersion. And if we say what do you mean by dispersive power, then dispersive power is nothing but dispersive power, that is nothing but is the ability to disperse the constitute color of incident ray. That means it is able to disperse the constituent colors of incident light. And this perceived power can be written as the ratio of angular dispersions to the mean deviation position, and you can say that is by delta r, and this is the mean deviation. If you consider this because mean deviation will be reduced, it will be that mean deviation is the deviation that is suffered by the, this is possible, you can say mean deviation. If it is not given, then actually mean deviation means the deviations, because your light is taken as a middle of all the lights, so you can say that that is deviations that is suffered by the yellow light, that you can the angle of mean of deviation. And also we know that this theta is, this can be written as del v minus del r, and also it can be written as n minus into minimum deviations. You can write like that, n minus 1 into a. So from, if we put this, we will get nv minus nr by n minus 1 as a dispersive power. So dispersive power, that is depends only on the nature of the material of the prism. Dispersive power, that is independent of the angle of prism. Dispersive power is an dimensionless quantity and has no limit. And of course the dispersive power of a material, that is measured for blue and red light in an experiment. So you can say the dispersive power of the material of the prism, you can write like that. If there is no yellow light is mentioned, so you can take, that is the blue light and red light divided by 2, that also as a refractive index, the refractive index of your light is not. So the thing is, there are certain experiments that will be shown here. I am not going details to explain the experiment. It is better that you should read it from your books, that, but the experiment that you need to know, that is, first is rainbow. First is rainbow. That rainbow, you know, that is the illustrations of dispersions of light, and of course you observe during the rainfall or after the rainfall, or when you look at a water fountain, whatever be the thing. And of course you just remember the thing that rainbow, that is formed, that is due to the dispersion of light, that is suffering refraction and reflections in the droplet that will present in the atmosphere. So the rainbow is the combined effect of refraction, reflection and dispersions of light. So you can say, just a point I am writing, you, there is a concept in every book, you just read it from there, that the rainbow, you can say it is formed uh, due to this of light that is suffering refraction and reflection in the drop, in the drop present in the atmosphere, present in the atmosphere. So thus you can see rainbow is a combined effect of refraction, reflection and dispersion of light. And another thing that you should study from your books, that is, you can say the concept of scattering of light. So the actually the process of radiating the light by atoms and molecules in all directions scattering. When the sunlight that will enter the atmosphere of the earth, and you know that this light is absorbed by a small atoms and molecules of the gases that is present in the earth's atmosphere. So these atoms and molecules that will re-emit light in all directions, and the process of scattering of light, you can say that you can say can be represented as scattering of light. And you will find that uh, we know that Rayleigh is already been told that the intensity of the scattered light that will be proportional to 1 by 4 power of the incident light, provided the size of the light is very less as compared to the incident light. And so you can see phenomena due to scattering of light like a bluish color of sky, reddish sun at the sunset or sunrise. The clouds are generally white. Of course, the danger signals are red in color. That all are due to the scattering of light. And of course, the danger signals are red in color. You will understand that we know that the red light will suffer less deviations. So when the light falls on the signal, all colors are scattered much more than the red color. So the red color suffering least scattering, that will remain confined around the signal, so which in turn that will illuminate the signal significantly. So you can say the signal can be seen from very far off distances. So that is the reasons. And also you will find that reddish sun or sunset at the sunset or sunrise, that is also due to the, you can say, the scattering of light. So that is the total thing that we study in prism. So there are some formulas that we already been studied. I'm just writing one by one only the formulas that would be useful for solving different problems. One is this, you can say, the deviation is incident light minus angle of, and from can find delta is equals to n minus a into L if we consider uh, uh, the prism of small angle, that can be, for you can say, very thin prism. That is the second that we did, you can say, the prism formula. And you will find the prism formula that the refractive index can be written as a plus delta m by 2 divided by sine a by 2, and delta m, you know that deviation when we place the prism at new. Then we will find that the dispersions of light, and there is a Cauchy's formula, a plus b by lambda square, that is the relation, that is the cause of dispersions. Then what we will find that, what do you mean by angular dispersions? That is the deviations of violet light minus deviation of the red light. Either you can represent at refracting index of violet minus refracting index of red light into A, and then we will find the dispersive power, and that is nothing but this theta by mean deviations, that is by delta. And otherwise, if we write it in refracting, that is refracting index of violet minus refracting index of red in minus 1, and n is taken as a refracting index for yellow. If yellow light refracting index is not given, then we can write by 2 like that. So that is the corresponding formula that we discussed and we in prism. Now we will solve some of the problem that you will understand that what type of problem, and of course that is a formula dependent thing. You will find that that is totally formula dependent thing, and the questions will also come in boards. Of course that will come from this particular theory part, or some problems will be coming just putting the values. So uh, let whether we can solve it or not. We will see that I'm giving two problems. Just try to find it. The first problem, say you have to find the limiting angle. Find the limiting angle of incidence of rays on the first phase, you can say prism, which will just from its second phase refractive index of the prism, refractive index of the prism 0.333, and its angle of refraction is pi by 3. That is the first question. And the question, one phase of a prism of refractive index 1.5, angle 75 is covered a liquid of refractive index 3 root 2 by 4. What should be the angle of incidence of light, the clear face prism for which light is just totally reflected at the liquid covered face. So that is the two questions, and I think solve করে তোমরা বলবে। দেবাদিত্য বলো। দেখি বলো, দেবাদিত্য বলো বা স্নেহা বলো দেখি। অভিনব। ওকে, মাইক খারাপ, যখন অ্যান্সারটা দাও দেখি। অভিনব, কোশ্চেন্স বোঝা গেছে? করছো কি?
হ্যাঁ স্যার।
ওকে, করলে হলে আমায় বলবে। ফার্স্টেরটা 30 ডিগ্রি। 30 ডিগ্রি তো আসছে না। কোশ্চেন 2? না, 30 ডিগ্রি তো আসছে না।
क्वेश्चन 2 तो बना 48.5।
48.5? কত আসছে ওটা আমায় দেখতে হবে, ওটা ক্যালকুলেশন করে।
স্যার ওটা ওটা বলে ঠিক করেছি 48.5 হবে। ফার্স্টটা দেখছি।
ওকে, কোশ্চেন 2 ইজ 48.5। দ্য সেকেন্ড, ফার্স্টেরটা দেখো পারো কিনা।
ও আচ্ছা স্যার এক মিনিট ভুলে গেছি পরে বলছি।
ওকে। From the first question সেটা আমি কি জানি যে ray of light will just come out of the second face of the prism কখন যদি R2 is less than critical angle হয় যদি R2 is less than critical angle হয় then আমরা জানি যে light will just come out from the second face of the prism. So it's about the mathematical calculations that what we can say that this ray of light just come out second phase of the prism. We know if this is less than critical angle and plus R2 is equals to A. So if we place there, then we can write R1 is greater than A minus C. That we will find from there. So for the refraction at the first surface, if we consider refraction at
Sir, 11.9.
yes 18 point. So when we consider refraction at the first surface,
18 না 11.39.
আর একটু ক্যালকুলেশনস মনে হবে ঠিক আছে মোটামুটি বাট ইট শুড বি নিয়ার অ্যাবাউট 15. Right into sine r1 or you can say that sine I is equals to n sine r1 because n1 is 1 for here and since sine I, so we can say is greater than equals to sine a minus c because r1 is greater than a minus c, and if you can break it in formula that it is sine a cos c minus cos a sine c, or you can write like that this is sine, you can write 1 minus sine square c minus sine c, and since you can write that sine c is 1 by n, so from that sine I written as n, this is sine a, and since sine c is 1 by n, it should be n square minus 1 by n minus cos a 1 by n. And so since you have to find the I, that should be sine inverse this sine a, this is n square minus 1 minus cos a because it is cancelled. And now if you can put the value that a is 6 and n is given that is 1.333, so sine inverse this is sine 60 minus like that 1.333 whole square minus 1 minus cos 60, and if you calculate it may come like that. So this is the procedure by which you can solve the problem, and I know second problem is more easier than the first one, so if you tried it I can sure that you can solve it. So now we will solve another problem. Let's say what we can say the problem is like that. Say the problem is say for a 7 by 3. Minimum, you can say, possible angle of incidence, so that, just a minute, just a minute. So what we write, that for a prism, that is A equals to 60 and N equals to root 73, you have to find minimum possible, you can say, angle of incidence that light ray is refracted from the second surface, and also you have to find maximum deviation. So what we can take, if we take this is a corresponding prism, this is the I minimum, that is, and of course it will be passing through this. This is the, you can say, I minimum, this is the angle, and of course this is should be C, so that portions you can say that be treated as A minus C. So in minimum deviations case, the angles will be as shown. So if we apply